So if you saw the title, yeah, we're going to be doing some back to basics with ESPHome. And before you Tasmota users, hardcore ones like myself, click off, stay around because it's definitely cool to learn both projects because it all applies to all the various chips, even the Beken ones. We did that to you, the cloud cutter. Those are all don't be supported by Tasmota, but they are supported in ESPHome and ESPHome because ESP supports ESP8266s such as the S31 plugs, ESP32s, all the cool products you see out there, and you're probably scared of seeing some of that YAML stuff. Well, we're going to jump in and try to break some of that down for you, and that way you're not scared of some of that different things of adding devices that you bring into Home Assistant with all the things. So we are going to be using the ESP8266 little NodeMCU here. It's a little breakout board, but the cool part why we're doing that is the little port here. If you screw up on your firmware, you just plug in and rewrite it. There's no soldering here on this video. It's all going to be just a few things thrown together, and I do promise we will get to the whole OTA password debacle with ESPHome. So let's jump in. So anytime during the video, if you have a question or comment, definitely feel free to leave it down below. While you're there, give us a thumbs up, subscribe, whatever it may be. If you really get stuck, there's also the Discord link. You can come jump into the digiblur DIY Discord and ask for help. Tons of cool people there, and come hang out and have fun. So what exactly is ESPHome? Think of it like a program that allows you to put some code or little programs that you don't have to be some master engineer on these little devices that control relays. They got buttons, lights, got power monitoring. It's on pretty much a ton of different things. Anything you can think of pretty much in the home automation world, we can really use with an ESP chip. Now, they have broadened out from ESP8266 to ESP32s. As things just evolve and get better, there's even some Raspberry Pi microcontrollers, and then you'll hear about the Beken chipsets. All it is just a little chip, and then you'll hear them called SoCs, system on chip. And it's really, that's what it is. It's a whole CPU, like small computer, and even most of them have a Wi-Fi chip in there as well, so we can put them around the home. They run on low voltage. They can do all the cool things, feed everything, and then we can control them using Home Assistant, Node-RED, automations, whatever it may be. But you don't have to be a super nerd to know like C++ programming, everything. You really just, and I'll tell you a secret, you just need to be able to copy and paste. There's so many examples out there. I don't really remember all of the stuff, and I just take pieces of code and copy and paste it into mine and cross my fingers and get it to work, right? It's trial and error. So the first thing we need to do, if you're a Home Assistant user, if you're using the HOS, yep, you know the deal. It's fairly simple to go to the add-ons, install the ESPHome dashboard. You can click here, show up on the add-ons on your HAOS. It's that simple to get it installed into Home Assistant. Now, if you're not, there's the manual methods. If you want to just run it on the command line, you can. You may not get the GUI. There's Docker Compose. All there to meet everybody. I know I do just the Docker container things. The Unraid users, you know my buddies out there. Jump over here into the apps. Just search ESPHome. You'll find ESPHome here by this digiblur guy repository. He's kind of shady, just, But you can do the install there. Follow the stuff. It's a simple little Docker container, and it starts up and gets the same exact dashboard that you would in the HOS world. Now, if you already have ESPHome installed, do make sure you're running the latest version. As the recording of this video, 2023 11.6 is the latest. I know some people really have some old dashboards, something they haven't touched in a while. So do make sure you update everything. And before you do that, go ahead and back up any YAML files you may have in there. But there also is the create backup for updating for the HOS users. So once you have your dashboard ready to go, you're going to have no devices. And simply the devices are just small YAML files. And if you want to edit them manually, you can. If you want to drop in YAML files in your ESPHome config folder, it should pick them right up. But you really don't need to do any of that, behind the scenes manipulation. So we're just going to hit new device. And you can install things some other ways, but I'm going to do my own way that's like simple to me. So I'm just going to hit continue. First, you want to start off with your name of your device. I'm just going to call this one my NodeMCU-test. Now, if this, of course, your first device, it's going to ask for your Wi-Fi, SSID, and password. So go ahead and put those in. And once you do put that Wi-Fi password in, you do probably want to go check it in your secrets file to make sure you did type it correctly. So now you're here to select device type. And I know I talked about the Beken chipsets. They don't have it listed here, but you could just pick one if you're building one for a Beken one, and then you could overwrite and change the chips. Don't freak out. I've seen people like, oh, which one do I pick? But we're going to be doing just the regular ESP8266. I'm going to say skip for right now because I don't want to install it on my NodeMCU just yet. Now, we have it here showing offline. Now, don't forget, I told you about it. Go check your secrets. Make sure your Wi-Fi, SSID, and password are correct. And do take note, the default method, this secrets file is different than the secrets file of Home Assistant itself because, this is a different module, add-on, Docker container, etc. So now we're going to get into edit our device. Now, it's YAML. Yeah, everybody's seen YAML. Don't freak out about it. It's just a lot of different things. I don't remember all the damn tabs and spaces, everything. So I just go copy and paste stuff out the docs. So we've got our name, NodeMCU, friendly name, and it's the board. You don't have to worry about changing that. I'm going to hide this over here and see if we can zoom in a little bit for some people. So now the logger, we're going to leave that there. The encryption, totally up to you. I don't use the encryption. I have a private network. I'm not sending this out. I don't have a public, like a network in a business or a university or something like that I would have my devices on. So I don't need my encryption. It just creates another step for me. If you weren't wondering about the whole password deal, the OTA password, if you just delete the password out on a device that's already there, that's a bad idea because once you lose that password, you're going to have to manually flash this device, and that could be something you have to solder or whatever. So if you ever put a password on a device, I'm going to say it again, do not lose that key. Again, I'm not on a public network. If something is doing stuff on my network, I have bigger issues than my ESPHome devices. So I'm just going to nuke it out of there. Wi-Fi, you can see that points to your secrets. And then this is a very good idea to leave this in here, is the fallback hotspot. Now, I don't really need a password on it. That's totally up to you because, again, I forget the password. What this allows you to do, if for some reason this device cannot connect to your network due to like you got something wrong with your network or the password is different or whatever, and say it's something you've got that's up in the ceiling and you don't want to can't take it down to reflash it or whatever or reset it, this is where you'll just connect with your phone and change the SSID and password on the device and reflash it with reflash it with the correct SSID and password. For simplicity's sakes, I'm gonna go ahead and nuke this. Totally up to you, don't have to. The AP will just default to being the name. It'll be NodeMCU test. I know it's the access point. If I see that name, I really don't need to be some other special name. Captive portal, you need to leave the captive portal in there because that's going to allow you to put it on your network. So really right now, you're done. This device, we can go ahead and install it, and it's exactly what we're going to do because I don't want to start adding anything to it. It's like I try to get my rolling chassis first of things, whether it be a light switch or whatever it is, and get it on the network, try it out, and then you can add stuff to it, and then you can just install it over the air. That's the cool part about all of this. So do make sure you hit save, and we're going to hit install. Now we can't do it wirelessly just yet. So, yeah, you can plug it into this computer. I really don't like to do it that way. Plug it into the dashboard with a whole VM thing or whatever it may be. You may not be able to plug it into it. I'm just going to use the manual download method. It's pretty easy to do. Once you hit manual download, it's going to go through, it's going to compile. Some of the people on the Pis, the Home Assistant Green, this may take a while, I'm sorry. Others, it may go fairly quickly. The first one is really going to take long because it has to install all the toolkit stuff, as you can see there. But once we start to make little small changes, it doesn't have to recompile the whole thing. It'll just put in small pieces and compile that. It's fairly quick. So once you get to this point, it says success. It will download the bin file to your computer. Now, we do need to go over and write this to our NodeMCU. So remember, I'm just using the little NodeMCU with the USB adapter on it. And I'm just going to plug in my USB cable. It is the older school micro USB. Some of them have the USB-Cs on them. And just go ahead and plug it in. If you're on a Windows computer, if it's your first time using a NodeMCU or any type of flasher like that, do make sure you go check your Windows Update, your device manager, drivers. Look for a new device there. You may have to install a driver like the CP2102 or whatever it might be on your chip. But a lot of times the Windows Update will have that. You just got to go hit accept like under the optional updates. And of course, if you ever forget any of these steps about creating your new device, this says say ESP32 on my website. Of course, I'll leave all the links down below. You can follow through this. It has all the steps and screenshots, etc. So now we need to put that bin file on our NodeMCU. So what we're going to do is hit connect, and mine is a CP2102. I'm going to hit connect. You may be tempted to hit this prepare for first use. I don't use that method. I already have mine ready to go. So I'm going to hit install. And I'm going to go ahead and pick my file it just downloaded. And then I'll hit install. At this point, especially with the NodeMCU, it should just fire off. You don't have to hold any buttons down. But some of the ESP32 NodeMCUs, they make you hold down that boot button while you're plugging it in. Kind of puts it in that mode like you're trying to go in right to the BIOS. But most of them should automatically jump in. Now, if you're using another device like say you're flashing a Sonoff Basic or something like that, you will need to hold the button down on those to get those into boot mode. It varies per device. So we got configuration installed, hit close. It should be ready to go. And sometimes it may take a little bit to come up, but you will see it shows online. And then we get the logs, and we're going to get the logs wirelessly. And there we go. We have it on our Wi-Fi. Now, this is where we can start adding some of the other cool stuff. So one of the things I like to add next is going to be the web server. Just come over here to the ESPHome documentation. And here we are, the web server component for this. Now, it does say port 80, but that's already default. And so you got to do is just copy that one little section. There are other things you can do to add, like authorization, username, password to pull up the web page on it. But we're just going to throw it in default and call it a day. We'll paste it in here. ESPHome, if you don't know what a command is, if you just go and say I'm web server and hover over it, it'll show you that component, and then you could actually jump to it. Like OTA, I didn't say if I didn't know what OTA is, you could just hover over it and then go to OTA component, takes you straight there. That's a pretty cool feature to link to the docs. Now I've only added that web server. I'm going to hit save, install. Now here's the cool part. I don't need to have it go back and get the bin, use the web page. I could actually go put this across the house and still, as long as I had it powered up and hit wirelessly, and it will go ahead and send over that new bin file right over the air. So all your future updates and everything you'll do is, you'll be sending that straight over the air to your devices as needed. So there's this uploading. Doesn't take that long at all to upload. And just don't power cycle it while it's doing the flash and the reboot. That's actually when it's writing to the chip. Just give it a second, be patient. It'll flash itself and reconnect to the network. Now behind me, what I'm clicking on, if you're probably wondering, there's a stop button back here. It's not actually stopping the device. You're just saying stop this window. So I'm going to hit stop and put me back to the dashboard. And you'll notice now we have a visit button as well as the edit and logs. Now I'm going to go over the settings of what these different buttons do here. But visit, that's going to jump you to the actual web server on the NodeMCU itself. So this is actually coming from your device. How cool is that? A whole web page from the little chip itself. Now we don't have anything down here. Now there'll be logs over here if we have something, but nothing's really going on with this chip yet. It's just getting on our Wi-Fi and sitting there. So we're not going to add it into Home Assistant just yet because we don't have any entities right now. Now the other buttons, of course, you know edit, you know logs. The three dots have other different features in there. Validate, all the validate does is says, hey, is my YAML okay? And it says, yep, configuration is valid, and it has the little green check mark, and you could hit install, whatever. It's just checking your work. Now you can do show API key. Well, I nuked the API key. You can download the YAML. I've never used that one. Rename. That'll rename the whole YAML file and change everything in there and reflash that name. I've had an issue with that once. Do make sure you do your backups with this stuff. I have had it nuke one of my YAML files before. Now, clean build files. Don't be scared of that one. All that's doing, sometimes when you go to hit install, it may error out. Especially if you've changed a lot of stuff, like on the ESP32 or whatever, you've just radically changed the whole device. It's not a bad idea. Hit clean build files. That cleans the entire cache for building this device and makes it start from ground zero. It does not nuke your YAML file, so don't worry about that. It's just the temporary files, so it will take a little bit longer to build, but you know, that's there. I've used it a lot to fix some issues. Now, of course, there's the delete. We're not deleting things. The other cool things, you got the search up here. It's going to search for your devices if you have a bunch of them. I really wish they would have a smaller, like, tree kind of thing where you could categorize them and not these huge blocks, but maybe we'll get that one day because when you've got like 50 devices in here, it's a pain. So there is update all. Mash it. Pretty simple. It'll update all your devices. It may be good, it may be bad. You be the judge of what you want to do with that. So now we're going to go back to this device, and I need to add something we're going to do an LED. I'm going to do a button on this just to kind of mock up like a smart plug would have. You got a button on a smart plug, you got an LED, and then you got even a relay on it. So for my particular setup this is our little NodeMCU, and I'm going to be using a little breadboard adapter just to show things. Now, you know, of course, if you want to use like a real Shelly 1, a real light switch, whatever, it's all going to be kind of the same S31 plugs, but this allows us to test things and really not worry about messing anything up or trying to do any soldering or whatever it may be. So we're going to put this in a little breadboard adapter, and that will allow us to put the cool little jumper wires and just do this prototyping and dev work. And I'm just putting in a little button, and then we'll throw in the LED. So the longer pin is ground, and then the others are the red, blue, and green. So I'm just going to shove this into ground. So I'm just going to use the red pin on the LED. It's a multicolor LED. I don't need all three colors. And then I'm just going to shove it into one of these GPIO pins. That's the general purpose input output. And basically think of it's like different channels or addresses on the chip to, you know, drive things in or out. And we'll get to that in the code because you're going to say, hey, I need to send an output to turn on this number. Now, the button here, I'm just going to tie that to ground, and then I'll tie the other side to another GPIO pin. So pretty simple setup here. We've got a button just to mimic, like say on a smart switch or something like that. That's going to go into D6. And then we're going to have an output for the LED on D5. And let's go jump into the YAML and get this set up and copy and paste some stuff to be able to control the LED with this button. So first thing I want to do is let's go set up the light. I did put that on D5. If you're ever curious of because I really hate on the 8266, the D pin numbers. There's an awesome reference on Random Nerd Tutorials. If you scroll down here, you look for your NodeMCU, you can see they have the map of this thing. I think the whole Wemo's D1 Mini started this junk, but maybe I might be wrong on that. But you can see we got D5 is actually GPIO 14. In the ESP32 world, they don't do that stupid D number. They just go with the actual GPIO numbers on the chip. Somebody thought it would be a good idea to map these things in stupid ways. And they also have in here, if you're curious, if you're building something, they have best GPIO pins to use for certain things, because some pins are good and some pins are bad to use. I wouldn't say bad, maybe just limited on what they can do. So back in the docs, I want to go grab a light. It's going to be an output like light components. There it is, light. I just want to do, now they do have a status light on the actual NodeMCU. We're not going to be doing that one just yet. I needed to grab just a single color light. Now, of course, if I did hook up those other pins, I could have done an RGB light, but we're going to do monochromatic light, just single channel. Keep it simple, stupid. Yep, the whole KISS principle. We're just going to copy and paste. Back in our YAML file, paste it in, cut out that, I don't need that. You see it says light, monochromatic, kitchen lights. We're just going to call, I don't want to confuse it with my whole setup here. We're just going to say, and now this is where things can get confusing. And I know we're just talking about copying and pasting, but I want to try to explain some of this stuff. The platform, monochromatic, you're doing the name. Now, if you don't put a name on it, it's going to keep it internal. It's still going to assign it to the chip, but then you won't be able to see it on Home Assistant. So very important to put the name. Output, you're giving it like a custom internal name, because we need to tie it to the output of well, how does it get that light? Is that a light driver? Is it some other deal? Because there's tons of different ways to control lights with ESPHome. So now in the output section, there's a platform. We are using an ESP8266. Now, if you're ESP32, there's LED-C drivers. There's also in Beken, you have different ones. Check all the docs based on your chipset. PWM, it's going to allow us to make the light, bright or dim. Notice ID output component here matches here. The pin is D1. You can use the D, but then, no, not that one. But you can use GPIO numbers. So I did D5. We're going to put D5 there. I'm going to go ahead and put GPIO 14. Sometimes some board, it gave me an error saying D5 wasn't any good. So I want to go back and check to be sure D5 is GPIO 14. It's not a bad idea to just use the GPIO numbering scheme, I promise you. So we'll go ahead and save this. And again, we'll hit install and do the whole wirelessly thing. I'm going to cut this part out and jump to when it's done. Once it's flashed, go back to the visit. Use baby steps. I know we're going through taking time, but this is the way you learn. Go back and hit visit. Now you'll notice, guess what? We got an entity now, red LED. The state is off. I'm going to go ahead and turn it on. You should be able to see it above my big head. There's the red LED. It transitions. There is, this transition length is 1 second. That's a default setting. If you don't like that, you can change it to make it shorter or longer. Now, let's test to make sure we can dim this thing. Yep, sure enough, we can dim it way down. It's an LED and pretty slick stuff. We just added a simple LED and we didn't really do any coding. Now, let's go ahead and add that for the button to turn the light on and off. Now you may be tempted to jump into here to hey, I want to look at the button components. It's a little bit different because it's actually going to be a binary sensor. So we're just going to do the binary sensor. Now, if you want a good example, and maybe you don't want to come in here and do a binary sensor, and you're confused about it, about, hey, the pull-ups and everything, and the pull-up resistors. And let's go look at one that works. Let's jump into my website. Let's look at the Sonoff S31 plug we just covered recently with ESPHome and Tasmota. You'll notice a lot of the same stuff. And now that you've kind of got accustomed to this, you can probably read some of this. Now, you maybe not be able to write it. That's very common with some programming languages, you want to call it that. But you can read it. You can copy and paste it. So now I'm going to take and copy this binary sensor out of here, sensor here, and I'm going to comment this out because I don't want to do the on press event yet. So here we are, binary sensor. That's a module of ESPHome. The platform is GPIO, so it's going to be an input on a pin. So now it's going to ask you, well, which pin? There's GPIO 0, that's the Sonoff 31. We're not using that pin. We're actually, remember, we did the D6, that was GPIO 12. And then mode, input pull up. And now this probably is not the time to go over all of this because there's a ton of different ways. But basically what's happening is the pin is waiting for, and we tied ours to ground. So when we push the button, it's going to pull that to ground. Well, you don't want that flapping in the wind. So what happens is you tell it to do a pull up. Well, the chip keeps it up. So then when it pulls it down, it can pull it down. So it's kind of like, think of it spring loaded. And so that's what we're going to do with input pull up. And the inverted is not going to be true on this one. I don't believe. But we'll see. Let's do false. You don't know? Give it a shot. Screw it up. Go put true. So we're going to call this the button. Sure enough, that sounds good. I commented this out just using the #, or if you're one of the younger ones, the hashtags. So we'll hit install, do the wirelessly, and let it update. And then we'll go jump into the web page, see if we're right on this thing or not. And hit visit. And for some reason it doesn't refresh. You may need a refresh. Now, I look like I was wrong. See, it says on. So when I push the button, it's pushed down now, it goes to off, and then the button is on. So I was wrong there. So let's go ahead and change that to inverted true. So now we get the off, and we push the button. There's the on. And now we're just going to go put in a on press to actually turn that light on. Uncomment those. This is going to be a light, not a switch. So let's just change it to light. And, oh, we don't have an ID, the internal ID on the actual light itself. So let's go add one. Let's do ID red LED. And so then light toggle red LED. So basically on press, toggle the light. Now you'll notice all this is happening on the chip itself. We're not making automations in Home Assistant. So we haven't even put this in Home Assistant yet. It's all happening internally. So now we go back to visit. Once we did that, we should be able to, if I just push the button, and you can see just pushing the button turns the LED on and off. So that's just like a light switch. Whether you push the button on it, it turns on the LED, or it would be a smart plug that has a button on the side, and then it just turns on the relay or whatever lights, etc. You can see really the simplicity of how this is set up and configured in the YAML file itself. Now, this is all fine and dandy, but how do we add this to Home Assistant and control it in there? This has been nagging me down here the whole video. If your auto discovery works, MDNS discovery and all that works on your network, if you click on this, you should see a new component, and I have quite a few here, but this is my test box. So look, there it is, NodeMCU test. I can dig through there, hit configure, and we can hit submit. It automatically puts it into my ESPHome integration. If it's not there, you can hit add integration and actually go put in the host name or the IP address of the device. And that would be if your MDNS, auto discovery, everything is not exactly working correctly. That can be a very whole thing depending on your setup. So come into here, we should get NodeMCU test, and I have seen this quite a bit. When you add something to it, you just need to refresh the page. And then you'll get the other sensors once it refreshes. You can see we get the red LED. There's the buttons showing the off. And see it shows the on. Goes very quickly because this is all local. If you do pick up the red LED, the stupid entity card, you can change the dimming level there. I slid it out of the frame of the camera. That's what we get for being unscripted, right? But that's how you add a device all in straight into Home Assistant and build it yourself. And then you can see adding more buttons and more relays and everything. You really just need to go through and just add more code to your YAML, pull stuff out of the documents, or adding sensors, etc. And then you get really stuck, go dig around. Hey, I want something that I'm going to pull out of here on, say, this Wise Plug outdoor outlet. The YAML file gets fairly big. I got 2 buttons. There's 2 outputs. There's a light. There's a lux sensor on this. There's power monitoring. There's a binary sensors. There's a status LED. We can go pull the status LED in for ours. But you can see the thing of this. If you want just this, go copying that. Not stealing somebody else's code. You're just taking modules that someone else already wrote. You can read it, but you maybe don't understand exactly how to write it. I never remember. Just paste it into yours and call it a day. Make it work. So hopefully this was able to get your feet wet and dig a little deeper into more than just copying and pasting an entire script and just hoping it works. Now, if you can see how easy it is. If you want to play around with some sensors, air quality sensors, you build your own thing. You can do Bluetooth stuff, distance, electricity, the whole 9. Probably something I would probably get into just to maybe add a little more to things, and is probably get into some of the like temperature sensors, like say the AHTs. They're I2C. It's a little bit more than what we're doing here in this video, but you can see here, it's all copy and paste. You want the sensor in there? That's pretty much it. You add the I2C section. You follow right along in the docs for your sensor and call it a day. The docs are pretty damn good on here for having to do all your things, you know, for whatever sensors you need. So if you got any other questions on things, you really get stuck with something, you got a weird device, whether it be like a dimmer, a switch, or some of those Tuya MCU secondary deals, and you don't really know some of the things on there, maybe we can cover some of that, but we can definitely help you out in the Discord. You'll find that Discord link down below in the video description. So I do appreciate you watching. All the YouTube members, Patreon members, definitely couldn't do it without you. Definitely shoot us a comment, press the subscribe, thumbs up, whatever it may be, and well, y'all take care.